Hi students, I'm back with lesson 5.6 part 2, Law of Cosines. Today we will be continuing just to practice the law of cosines, how it works, and taking a look at an example of applying it. So let's begin by reviewing our formulas. Here are our core formulas we use when working with the law of cosines. One thing with the formulas that you want to keep in mind is that the angle and the side length are always on opposite sides of the equal sign. So you will be given either an angle or a side that you're trying to find, and therefore you'll be given all the other information you need. The law of cosines is going to be used whenever the law of sines doesn't work, and I really strongly encourage you to use the law of cosines in a strategic way that allows you to have more options for finding the other values in the problem. For example, the law of sines doesn't allow you to find an obtuse angle, so therefore we want to make sure we use the law of cosines when calculating out obtuse angles. Let's go ahead and take a look at an example. Here in example 3, we are finding all the missing parts of the problem, and they gave us some information. So angle A is 55 degrees. Side B is 12 and side C is 7. In this case, we do not have a side and an angle that are across from each other, and we're unable to find any of the angles that are across from a given side. So the first thing we need to find is side A. In calculating out side A, we can set up our law of cosines by putting a squared by itself and then writing in the remaining parts. So we have 12 squared plus 7 squared minus 2 times 12 times 7 times cosine of 55. I can type this all into my calculator exactly as I see it. And when I did that, I got 96.64. Now this isn't a, this is a squared. So to finish solving, we need to take the square root of both sides. And in doing so, we get 9.83. Remember that we always consider only the positive value because this is a length, and we want to make sure that that's always positive. Now that we've found that side, we have secured an angle and a side that are across from each other, and we are now able to continue solving the problem for the remaining angles. We are going to use the law of sines to do this. So we have sine of 55 over 9.83 equals. Now, be strategic in how you choose this remaining value. Because we don't know if one of the other angles is obtuse, we want to make sure that we are not trying to calculate an obtuse angle using the law of sines. So as I look at my remaining two angles to find, I would choose to find angle C next because it is across from the shortest side. That means that I can rest assured that angle C is going to be an acute angle. Going ahead and solving for angle C, I multiply both sides by 7. And then to get rid of the sine, I have to use sine inverse. So taking the sine inverse of both sides, now is the point where I like to go to the calculator and type this in exactly as I see it. Sine inverse of 7 times sine of 55 divided by 9.83. When I did my calculations, I got 36 degrees. So angle C is 36 degrees. Now I'm able to calculate out what angle B would be by using the fact that all angles of a triangle add up to 180 degrees. So 180 minus 55 minus 36. Angle B in this particular problem is going to be 89 degrees. It was not an obtuse angle, but I did want to err on the side of caution and make sure that I was finding the angles that I could guarantee were going to be acute first. Let's take a look at another problem. In example 4, I'm going to begin by drawing out my triangle. Again, we've talked about how sketching a picture helps us visualize and better understand what we are looking at. My triangle does not connect. I should make it connect. All right. Next, it appears as though they have given us 3 side lengths. So therefore, I don't have any angles. I'm just going to label my triangle A, B, and C. Little a is 1, little b is 5, and little c is 4. Now, we haven't talked about this yet, but it does say to find all the missing parts. If you went through and tried to solve this, you're going to get an error message. And some of you might say, well, how do you know we're going to get an error message? Well, there's a fact in geometry that says that the 2 shorter sides have to add up to a value that is larger than the 3rd side. Otherwise, a triangle cannot be formed. So what this is saying is this length of 4 would probably take us to here. This is a length of 4. And the length of 1 would be this part. Well, 1 plus 4 equaling 5 doesn't form a triangle because it's equal to 5. The 2 sides that are shorter must add up to be more than that 3rd side. Otherwise, no triangle can be formed. So this is a little bit of a trick question. And it is intended because sometimes triangles can't be formed from the given information. So I wanted to make sure we talked about that a little bit today. All right, I have one more example for us today. Example 5 is a baseball problem. I know if you're anything like me, you're probably missing a little bit of your sports. So let's take a look at example 5. So in example 5, it says the bases on the baseball diamond are 90 feet apart. And the front edge of the pitcher's rubber is 60.5 feet from the back corner. So from here to here is 60.5 feet. And then here is your 90 feet between your bases. They also gave us that this angle measure is 45 degrees. The question being asked is how far would the pitcher have to throw in order to get an out at first base? So they want us to find measure C. All right, well, I don't have an angle across from a side, so I can't use the law of sines, which means law of cosines is our only option. So we want to find C, and we know the other 2 values. So I'm going to go ahead and do 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times cosine of 45. Now, some students believe that all of these angles are 45-degree angles. They are not. So we want to be careful and we want to do the calculations correctly. So in doing all of this information, when I did it, I got 4,059.86. Again, that's C squared, so we take the square root, and C becomes 63.72 feet. In order to get an out, the pitcher would have to be able to throw the ball 63.72 feet to first base. So that is the second day of our law of cosines. As you can see, law of cosines is a lot more simple to understand. And so as you continue to work through your practice, be sure to check back to the videos or check in if you have any questions.